Are you interested in logarithms? Well, if so, stay tuned. We are going to consider logarithms, what they are, what rules they follow. I'm going to demonstrate these rules and convince you that they are true. And this is all done in a Mathematica tutorial. Okay, so let's begin. So here we are in my book, a YouTube course on Mathematica. And we're in the section 1.7 on logarithms. Okay, logarithms can be used to solve equations involving powers. In general, if we have y equal to a to the power of x, then this is equivalent to the equation log to base a of y is equal to x, or x is equal to the logarithm to base a of y. All right, now this is just the definition of the logarithm. So it is simply the inverse function of this function right here. F of x is a to the power of x. And it is useful in solving for the exponent. Okay, and a number of other things. All right, so a in that case, right? Remember what a was? A appears right there and right there. A is the base, and we can read this as the logarithm of y to base a is x. So if we assume that we're dealing with real numbers, then we need a to be positive, y to be positive, and a not to be equal to 1. All right, so the natural logarithm is very important in science and mathematics, and in general this number e is very important. It is known as the base of the Napier logarithm. So it was worked on, well, a number of things related to this were worked on by Euler, so that's possibly why we use the letter e for this number. Now look, I've stopped here at point blah 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 84, but this goes on and on and on. It is not algebraic, it is not rational, it's a transcendental number, meaning that it's not the root of a polynomial, and it's not p over q, where p and q are integers, so it's not rational. Okay, so this is the base of the natural logarithm. And we sometimes write it as ln for natural log rather than log to base e. I prefer to use log to base e because generally in mathematics, when we're talking about logarithms, we just assume that that is done in base e, and so we write log for that. We don't often write the e at the bottom. Okay, but if you are in a course in which ln is used, well, know that that just means log with a natural logarithm as the base. Sorry, a natural, yeah, e as the base. All right, so ln y is log to base e of y, and that's the power of e needed to produce y. All right, so here's an example. Determine the natural log of the cube root of e squared. So we say let x equal the natural log of this number, and then by definition we have e to the power of x is e to the power of 2/3, and so x is equal to 2/3. So we've calculated the natural log of this number, it's just 2/3. Okay, so we don't have to use a base of e to deal with logarithms. We can use just about any base, a. Okay, so two very common bases to be used in mathematics are base e and base 10. But more common is base e because it's natural. Okay, so we have a number of rules. Now, these rules are as follows. But let's first consider this 6th rule because that's just about the starting place. Okay, so let's open up a Mathematica notebook and start writing some calculations. See, I've got one open already. All right, looks like I was doing some basic calculations, so magnify this to 300, and I'll delete these cells. I'm right-clicking, cutting, cut, and cut, and so now I have a blank Mathematica notebook to talk to you from. Okay, so I'm going to start with this one. Now, what I'm doing here is I'm just writing the code. Sorry, not writing code, I'm just writing some comments. Okay, and then later we'll do a little bit of code. All right, so let's consider our first identity. Okay, so it is saying that log the base a of x in the exponent with a base of a is just x. So x is equal to a to the power of log the base a of x. Okay, so how do we do this? Well, it's just following from the definition. Okay, so let's say let y equal log, and in Mathematica, I'm just going to put this in Mathematica code for log, all right? But even though I'm just writing some comments out in order to demonstrate some of these rules. Okay, so log to base a of x. All right, so we've said let y equal to that. Okay, now what do we want to do? Well, what we have is a to the power of y is equal to x, right? Okay, so given that, if we have that, well then by definition, the result follows, okay? X is equal to a to the power of y. Okay, so that gives us this result immediately. So it follows that a to the power of this one has to be equal to just x. All right, so what we've done is we've just used the definition of the logarithm right there, and then the result just follows straight away. Okay, now let's consider this one up on the top left. Okay, so this one says, I'll copy it out, log to base a of x plus log to base a of y is equal to log of the product, all right, in the same base, log of x, y. Okay, so let's demonstrate this. Now, let's start with the right-hand side, okay? So I'm going to say let z be equal to, or z if you're in the United States, let z be equal to log to base a of xy. Okay, now let's consider the definition. Okay, then we have a to the power of z is x times y. Okay, now can we go any more with that part? Well, not really, and it's not really clear how you get the left-hand side of this statement. Okay, so now let's work with the left-hand side. All right, so I'll copy this, Control C, Control V, and over here I'm going to say let this be equal to W. Okay, so we'll let W be that, and now we want to say that it follows that, so a to the power of W has to be equal to a to the power of this sum. Okay, now at this point we need the rules for powers, and if you remember that if a to the power of b plus c is equal to a to the power of b times a to the power of c, well then you're good and you can get to the next line. Okay, so let's do that. We will separate this. So I'm just popping that underneath. All right, so that is a to the power of log a of x, and then that is multiplied by a to the log a of y. Okay, just by the laws for powers. Okay, so next we want to use the fact that, well, this 6 was result, which we considered first. All right, simply that this is equal to, this first one is x by this rule right here, that's x, and then this other one is by the same rule equal to y. Okay, so we have the product. All right, so in other words, a to the power of w is equal to xy. Okay, but you have a look at this. This is also equal to a to the power of z. So equal to a to the power of z. And now, since we have a to the w equal to a to the z, well, we have to have w equal to z. So w equals z. Okay, and what does this mean? Well, z was this one, so we'll say so, and then w was this one, so this one is equal to this one. All right, and that proves the claim. Okay, now all of this was just a comment, so I'm going to put bracket, asterisk, asterisk, bracket, and now it's in comment form. Okay, so let's come down and consider our next rule, this one right here, but this is almost identical to this one. All right, all you have to do is change the plus to a minus, and you soon realize that the result follows from this rule right here that we just considered. Okay, next one, log to base a of 1 is 0. Okay, so let's write that out, log to base a of 1. Now look, this is a Mathematica tutorial, so why don't we just calculate? Shift enter. Look. Next, let's do this one right here. So log to base, log to base a of 1, well, we're told that's equal to 0. Okay, now what we're going to do is take this a to the power of this. Okay, so I'm considering a to the power of this. Well, by definition, this is just equal to 1, right? Okay, so now remember that 1 is equal to a to the power of 0 by exponent rules. Now if we consider the exponents here, so log to base a of 1 has to be equal to 0. Okay, so that's that one done. Now let's consider the next one, which is this one right here. Okay, so this one says that n by log to base a of x is equal to log to base a of x to the power of n. In other words, we can pull that n down and put it in front. Okay, so how do we demonstrate this one? Well, look, this again comes down to rules for powers. So if we say, consider a to the power of b times c, well, that's a to the power of b all to the power of c. So I'm going to take this a to the power of that product n by log to base a of x. All right, and then our rules say that this is a to the power of log to base a of x all to the power of n. Okay, all to the power of n. Now, what do we have inside the bracket? Well, by our definition, which is this sixth property here, this inside the bracket is just x. So that's equal to x and then to the power of n. Okay, so this does not quite demonstrate our result until we take the log of both sides of this equation to base a. So let's say taking logs to base a, we have log to base a of this one is equal to log to base a of x to the n. Now what we have on the left hand side, because we've got log to base a and then a to the power of, well, that is just n log to base a of x. So this one is equal to this one. All right, and that demonstrates that. All right, now if you look at this sixth property here, that is just a consequence of this one right here, isn't it? That we can pull the x down, and then we're looking at log to base a of a, which is 1. So that is rather obvious. Okay, the last property that we have is this one that says log to base a of b is log to base c of b divided by log to base c of a. Essentially, you can change base here to your favorite base and introduce a letter c. Okay, now that c could be equal to e, it could be equal to 10, or it could be another number. Okay, but let's demonstrate this. Now, let's begin with writing out log to base a of b. Now the claim is that this is this quotient right here. Okay, but what we want to do is say let w be equal to that numerator, which is log to base c of b. All right, so if w is that, then we can say c to the power of w is equal to b. Okay, and so that means log to base a of b is equal to log to base a of c to the power of w. All right, now remember this other rule here that said that we can pull down the n. Okay, in our case, we pull down the w. So let's scroll down and say this is equal to w times log to base a of c. Okay, now w itself is, by our definition right here, is just log to base c of b. All right, so we're halfway there. So log to base c of b times log to base a of c. All right, now our last step is to show that log to base a of c is actually 1 divided by log to base c of a. Okay, so how do we do that? Well, for that, let's just say let z be equal to log to base c of a. Okay, given that, then we have, so c to the power of z is equal to a. Okay, now if we take both sides to the power of 1 over z, then we get c. So c to the power of 1 over z is equal to a to the power of 1 over z. Sorry, what I meant to do is c to the power of z all to the power of 1 on z on the left. Okay, which is just c. Okay, now if you're not careful, you can get multiple solutions to this, all right? But what we mean is the real one. All right, so now we have a to the power of 1 on z is equal to c. So that means that this right here simplifies. So this is equal to replacing the c right here with a to the 1 on z. Okay, and so This part is just 1 on z. So I'll copy that. 1 on z goes here. And now remember, z was equal to log to base c of a. So log to base c of b over log to base c of a, and we have our result. Right, but what was this? It was log to base a of b, where we started to say equals equals. Okay, so there we have the result demonstrated. Okay, now that we have these rules, let's learn how to use them. Okay, so let's scroll down and have a look at our example. Simplify log to base 10 of 24 minus log to base 10 of 4. Okay, so log to base 10 of 24 minus log to base 10 of 4. All right, now if I press Shift Enter, because this is a Mathematica tutorial, I should get a simplification of that. Well, yeah, I do. So what it's done is it's changed these to base e, all right, using this last rule right here. But maybe that's not very helpful in understanding what you're dealing with. So maybe you want to take a numerical value. Okay, so let's take a numerical value of that. And we get 0.77, 81, 5, 1, etc. Okay, but we have a rule for this. It's this one right here, our second rule, that says this should be equal to log to base a of the quotient of x divided by y. Okay, so let's take a numerical value for that too. Log to base 10 of the quotient 24 over 4. Okay, Shift Enter. We also get the same number. Okay, so you see that lends confidence to the result you've proved earlier. Okay, but you wanted to simplify this. Well, look, using this rule, we get this as our simplification, but 24 divided by 4 is just 6. So this is log to base 10 of 6. And because this is a Mathematica tutorial, what I want to tell you is that you can check your calculations in this way by pressing Shift Enter and seeing if they all agree. All right, yes, it agrees. And so you can have more confidence that you have done it correctly. Okay, and I believe that's all of the calculations there and examples, but these rules will help you simplify a lot of things in terms of logarithms. All right, see you next time.